All right, we are in chapter 4, which is an introductory lesson to functions. And today we're actually going to look at a few interesting functions and look at graphs and analyze what's actually going on and look at some characteristics of graphs. All right, so I do have a what's it type puzzle here, so take a look at that. And I'll tell you the answer at the end. All right, let's look at our first example here. The graph shows the volume of air in a balloon as you blow it up until it pops. So what are the variables? So it's crucial for us to know that this is the x-axis and this is the y-axis. And x is normally going to be time or distance. And the y could be almost anything. So in this one, it's actually volume, the volume of air as we blow up our balloon. And as we see, the graph is actually going up. It goes up here. So we are putting in more volume, air into our balloon until we get to this point where we actually have to take a breath. And we start to blow more air in the balloon, take a breath, and we repeat this process until the balloon finally pops and there's no more volume left in the balloon. Okay, here are two practice problems. If you would pause the video and try these, and we'll talk about what is actually happening in each of these scenarios. All right, so again, this is our x-axis, and it's time. And let's see, we have the length of a board. So it looks like the board starts off pretty long. Let's say maybe it's like 10 feet. And then all of a sudden, it loses some of its length here, and now it's a little shorter. And some time passes, and again it loses some more of its length. So what's happening is it's getting smaller and smaller. So we must actually be cutting this piece of wood with a saw. Let's see, in the next example, our x-axis is, again, it's time. It's usually time. Let's see, and we're talking about the cell phone cost and minutes of the call. So it looks like back in the olden days when cell phone plans had limits, you could only make 300 minutes per month, and then after that the cost of making those calls would increase. So it seems like as the more minutes you stay on the phone call, the more money it's going to cost you. All right, problem number 2 is, so we're going to actually look at this table and determine which of these charts goes with the data. So a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. So which of these graphs could represent the data shown in the table? So it looks like day 1, they had a total of 346. Day 2, they had more. Day 3 and 4, they had even more, and we could actually calculate the values. Let's actually take a moment and figure that out. All right, so from day 1 to day 2, there was an increase of 665 more downloads. From day 2 to day 3, it increased by 2,444, and day 4 even more. So if we look at this, let's just look at this first graph. This is a linear equation, and linear equations always go up by the same amount. So all we have to do is look at this piece right here. Is it going up by the same amount each day? It's not. It's actually increasing quite a lot. So let's look at this one. It looks like it goes off and then it goes up and then it levels off. So again, that's not the one we want. And then finally, if we look at this one right here, that seems to represent what's actually happening. So day 1, it would be 346, and then it would increase, and it would increase it even more each day. And this is actually called an exponential equation. So the correct answer on that one would be choice B. And choice D would be a linear decreasing function. All right, if you would pause the video and try this one. So it's showing the amount of sunscreen left in a can based on the number of times the sunscreen has been used. So again, we have some data here, and just choose A, B, or C. Which one represents what is actually happening? All right, so our data is written a little differently than the one above. It's actually written horizontally. We can change that if you prefer. So our X column would be 0, 1, 2, 3, and then our Y column would be 5, 4.8, 4.6, and 4.4. Now I didn't do a very good job of lining that up. There, that's better. Okay, so it looks like it starts out at 5 and it decreases by the same amount each day. So let's see. Now this one, it looks like it decreases by the same amount each day. So that could be a possibility. This one looks like it decreases quite rapidly, which that doesn't seem to represent what's actually happening. And then choice C, this also decreases each day linearly, so it looks like a line. And I think this one would represent our scenario better, because if we look at this choice, it decreases quite rapidly until we have zero. And if we look at our third day here, we still have some left. So choice C would be the correct one on that one. All right, so I want to congratulate you for hanging in there all the way to problem 3 here. We only have 2 more left. It's just this one. I'm going to ask you to try one. So our scenario is a model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. So what kind of sketch represents this? So this is a good picture of what represents our model rocket here. So as time goes on, it goes up pretty quickly, and then it runs out of fuel. So then it starts to fall back to Earth, and then the parachute opens, and then from this point, it has a steady descent. So that means for each second, it's just descending the same amount. And as we can see, it looks very linear. So that would be the case here. So now I'm going to ask you to try this one. So got it, 3A's. 3A. Suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. So then you slowly swing to a stop and sketch a graph what could represent your height from the ground as it changes over time. And you want to label each section. So what's the X variable and what is the Y variable? All right, so we have our X-axis, and we'll call that time, and the Y will be our height. So the idea is, as you swing, your height will go up if you go forwards, and your height will also go up as you go backwards. So you swing back and forth, and your height will change. So let's see if we can come up with a model for that. Let's see. So let's say you swing forward, your height would go up here, and so you lose momentum, so you're no longer increasing your height, so you go back down. But this time, you're going to swing back up, but you're going to lose a little bit of height because of gravity and friction. So we lose our momentum and we start to go back towards the center, and then this process will continue. Until the swing finally just steadies out and no longer has any height to it. All right, so I hope that helps. This has just been a very broad view and look at functions and graphs. Let's go all the way back to our What's It puzzle. If you said a pirate ship, you are correct.